like to present the research that we are doing on my PhD in the music technology group. So in the recent decades, musicologists have been using computational processes to assist the analysis of musical repertoires. And they have been doing so by first extracting data representations from music signals that might be very relevant for the analysis of these repertoires, but that are really complex to extract and really time consuming. And then also these computational processes have been using to process these representations at scale so that we can basically perform corpus-based research on big pieces of data, and we can obtain a better big picture of the repertoires, right? And at this moment, deep learning is the leading technology to achieve that. And as you may know, to develop a deep learning model or algorithm, we need pairs of input examples with expected known outputs, given these examples. So we basically train the model or make the model learn to basically map from these input examples to these expected known outputs. And we need a lot of this data. And in the music context, well-annotated and clean data of this kind is only available for a few repertoires, mainly pop and rock. So if we want to apply these processes to repertoires out of the scope of pop and rock, this data is basically missing. And therefore, we need to apply repertoire-specific approaches that take into account the musical characteristics of these traditions and also the characteristics of the data that is available, to basically design approaches that take into account these problems, but that are aware of these problems to get state-of-the-art results for these particular repertoires that are out of the scope of pop and rock. And our focus in this thesis is basically to focus on extracting these data representations with a high confidence so that then further research can be performed on top of those. So this tone that you hear that is made from a tampura is one of the most important instruments in the Carnatic and Hindustani repertoires, which are very relevant repertoires with a high impact worldwide, but that are a bit underrepresented in the research community. Therefore, we want to focus on these two repertoires as use cases, and then design methodologies that can be extrapolated later on to other repertoires. And at this moment, we have been focusing on first separating the singing voice from a mixture, and also to estimate the melody of the singing voice with high confidence for these two repertoires, because this data is really important to understand these repertoires, right? And at the moment, we have achieved state-of-the-art results for melody extraction and singing voice separation for these two traditions. And we have observing, in the case of melodic pattern discovery at the moment, that these improvements will lead to improved computational musicology research, better distribution, and better learning of these musical repertoires.